we'll be happy to do that. Okay. So now let us go to next session. Before that, introducing Rizwan, I would like to say that stay tuned in the YouTube live channel because that is an uninterrupted live channel. You have when you log in into YouTube from your username, so you can post your questions. Those questions will be posted here. Okay. So thank you very much for listening to me and my colleague Anita. This event is sponsored again, just to tell you about the Frusi Manufacturing Execution System. Okay. So thank you, Anita, for a wonderful demo. Thank you very much. I invite Muhammad Rizwan. Thank you, Rizwan. Nice seeing you again. Assalamu alaikum and welcome. I always wait for your session because you talk something very nicely about OT. The topic we talk about is how OT, operations technology, can help manufacturing organizations. We talk about some concepts and cases. Mohammed Rizwan is a specialist in securing IIoT, ICS, and OT devices for critical infrastructure with a strong focus on helping utilities modernize and safeguard their operational technology environments. He worked extensively on OT device management, secure remote access, and centralized compliance reporting. With deep expertise in NERC, CIP compliance, and cybersecurity frameworks, he supports utility organizations in strengthening resilience across their risks. Representing Subnet Solutions Inc., he actively engages in global cybersecurity forums, including Black Hat NEA 2025 in Riyadh. So thank you, Rizwan, joining from all the way from Riyadh. Thank you. Over to you. Your mic is in mute, it seems. Please can you check? No, no, not yet. We are not able to hear.
How about now?
Yep.
Yeah, thank you. So, thank you for giving this opportunity to talk about OT cybersecurity as a part of a global supply chain summit here in the sixth edition. So, so let me share my screen. Can you see my screen? Hello?
Yes, you can see. You can see. Yeah, you can put it in a power slide share. Yes. Yeah, you can just yeah. It gone now. You can just share again.
Yeah, let me. I'm not getting the full view of this one.
No, you can just share screen button. Check the entire screen.
Yeah,
Then click on that and then just share it. Then you can just put it in a slide share mode. Yeah,
yeah.
now we can see the presentation. Yeah, put it in a slide share mode. Okay, perfect. Yeah, perfect. Please.
So thank you again. So let me give like a brief introduction about myself and OT cybersecurity. So myself, Mohammed Rizwan, I'm working as a OT system architect at Subnet Solutions. So I'm also working with many different OEM and vendors. So to implement OT cybersecurity in bothly and in the industrial environment. So, as an OT, so many people are aware about the IT cybersecurity and how the IT security is implemented. But when compared to OT, you see there is a lack of knowledge sharing and lack of information about all those systems which are managed by the OT engineers. So the systems like whatever the systems OT has like it include the process control, the manufacturing, and all other uh, uh, conveyor systems and MIS systems. So all those systems are hidden before. Unlike IT, they were already exposed to the internet, but nowadays, when there is a lot of implementation about the AI and the IT OT integration, so you see there is a lot of information being getting out of the OT network and getting into the cloud and like this. So there is many major challenges faced in implementing these kind of systems, cybersecurity. So if there is any weakest point in those systems, if, for a hacker or for any activist, it would be easy point for them to get through those weakest points. And security doesn't work without without the clarity. So you have to have all information about your assets. So the majorly you have to keep account of your assets in the OT. Then those assets can be monitored and can be protected. And then nowadays there is huge requirement of the secure remote access. So you need people to the experts will be all over sitting around globally. So you need a team of engineers who are very well aware of the systems. They can access those remotely and get the job done. In OT, in generally there is who are the bad actors. So we need to identify. You have to have your own security level. What type of security level your process plant or your manufacturing plant would like to achieve. So firstly, you should define that what I am protecting against. So is it a downtime, or is it a competition, or a ransomware? What is the impact of this downtime on my overall production or overall business? So how my business gets impact. So that's the reason you are trying to implement the security. So there are many scenarios and many incidents happen all around the world. We know that which has impacted the production, which has impacted the business, and some business are out of business or because of the small mistakes they have done in the OT. So majorly there are different systems which are need to be implemented. Let me go from bottom up. So majorly first thing is we need to have training and awareness of the systems. Like what is the impact of OT cybersecurity if it is not implemented, and what is how you will respond to an incident immediately whenever this is happened. And then you have a continuous monitoring and logging on reporting of those systems 24/7. And then system hardening. So you provide right access to the right people. Not everyone has access to those systems in your company or your production area. Then patch management, how you improve the security and how you update the system. So this is also one of the key things which is impacting the manufacturing area. And then you have a endpoint protection, so antivirus and application whitelisting, and you allow only the application. So the manufacturing systems have many process control applications, and the specific applications don't allow only those applications to run on those systems. And then you have a clear identity and access management. So you know that who is accessing system, either be nowadays machines are talking to machines. So manufacturing a robot is talking to a conveyor or all those systems. So these systems also should have an identity. So you have proper implementation of zero trust and role based access control, all those systems. Then over that you have a detection systems which is detect the anomaly. So any abnormal behavior in your process should also detect. And so you should have a baseline first. So you implement what is normal in your system. Then anything above this baseline goes wrong, so system detects is like, no, something is abnormal in the system. And then you have implemented those controls. Then finally you have a perimeter defense, which is intrusion prevention. So you have an IPS called intrusion prevention system, which is the next generation firewall, protecting your perimeters of the network or whatever the systems you have. So these are the global trends in observe, like what are the different attacks on the ICS, and these are the percentage where these attacks were defended in all industrial and computer systems which are has happened by country wise. So in OT cybersecurity, you have like offensive and defensive. So offensive is like you are trying, somebody else is like the attacker or the hacktivist or some other entity is trying to uh, penetrate into your network or jeopardize your systems. Then you as a defensive, you will try to protect, identify, and detect and respond those attacks. So for now, like if you see what are the different standards in OT, so you have like each country has their own cybersecurity standard. Like India has different cybersecurity, Saudi has different cybersecurity, America has different cybersecurity standard, Europe they have GDPR and other NIS2 standard. So we see that different standards are needed in the OT cybersecurity, and then each process plant and medical processing plant need HIPAA and all other standards. So there is different standards that govern how the OT cybersecurity is to be implemented in that country and in that type of manufacturing process or that type of plant. So majority NIST is the one which is globally a reference for all of the world, like which has clearly stated that you should have different type of functional identifiers, which is mainly identify, protect, detect, respond, recover, and the newer version they have also added govern. So there are many different challenges in OT. So you see, like there is many different type of devices, process, PLC, switches, computers, industrial computers, all those systems which has a complex process and they are designed for the purpose. So when you have designed for the purpose device, so you should have a purpose-based cybersecurity implemented for those systems in line with the process. And the OT systems demand the availability when it is coming to the IT systems. Confidentiality is and integrity are more critical, but in OT availability is more priority. Otherwise, the systems or the process have downtime, and you will lose your production. So if you see here, like this is the major organization which is Purdue has developed this kind of architecture, wherein the process flow from the machines to the MES manufacturer execution systems and the ERP systems. So this collects the information. Nowadays, you see there is another layer getting added here. Over here is like IT. So here you will have new systems coming up for AI, and all those systems are trying to collect your information from the process level. So how you defend all those attacks and you new technologies penetrating your production shop floor. So this is the overall Purdue level architecture more in deep. So you will see here your robots, your process plants, and your sensors getting collected the information at different levels. So you see that here the information flow is from one level to another level. So there is no direct information flow from one level to another level. So you see here the information goes from the sensors, the PLCs or the motors to the next level, level one, and then from level one the information goes to level two, wherein the SCADA or your MIS systems, the process level systems in your shop floor. Then from level two to level three, and then you have a DMZ wherever you try to extend the system to outside. So you try to send this information out of your factory or your process plant. So you have a DMZ, demilitarized zone, wherein you allow only whatever is filtered traffic go out of your network, or whatever has to be come into your network through the DMZ. So you see here each level of information goes to the next level, and then from there to the up. So it is not allowed to any, if there is any information or a HMI talking to a machine is not allowed here. So it should talk to a PLC, and PLC will talk to the robot or the machine. So if there is kind of information flowing from one level 0 to level 1, this is kind of anomaly. This can be detected by different type of systems, like we have in the system we have in place is called intrusion detection system. So intrusion detection system uh, is kind of detection. How it does is like it collects the information from the process level traffic, and then pushes ingests this traffic into the sensor, and this sensor has already built-in algorithms to detect all the OT framework, all OT issues related to that process. So you have an energy plant, or you have a robot manufacturing plant, or you have a manufacturing process. So all these processes are already defined. So based on those definitions, the system detects like what is normal, what is abnormal. So you see here like different detections, like vulnerabilities happen from level 1 to level 0 to level 1, and level 2 to level 3. And then we have pure all pure security parameters. So So you see that nowadays, when the companies are getting implemented OT cybersecurity, there is reduction in the security parameters issues in the OT. So this is another architecture. So you have a factory or a manufacturing plant. So you have to enforce different layers here, like OT and control layers. So you should have all those applications, your product applications or process applications, being monitored and controlled. So at any point of time, you can isolate those store systems, and then you have your production run manually. And this is one of the systems where you have to implement the zero trust and role-based access controls, give the shop floor or the manufacturing users only the rights, and based on the policies they have you have implemented in your company. So go through the process, day-to-day process in your manufacturing plant, and identify the people who are based on their roles, what are the access, what are the systems have access, like this. And then you should have an additional system which is out of your process in corporate headquarters or your head office, so that you bring all those security information to a single dashboard. So you bring all the information from the switches, the devices which you have implemented, to a central place, central location, so that in case you have an issue with process plant, you can deep dive into this data, and then investigate what went wrong on those systems, and what was it, a security incident, was it a malfunction of any device, or misconfiguration, so you can identify and then avoid those things in the future. And then patch management, so you should do patch management on a regular basis. So how you patch all those devices, how you make protection of those devices, and update. So you update only the devices which you need to update, and don't update the devices which are not needed and which are running normal. And then you should have a regular backup. So when you implement all those systems, so you see here different machines. So in the process plant or your manufacturing plant, you have MIS systems, you have inventory systems. All those systems should be backed up to a central repository, so that in case of downtime or in case of any issues with those systems, so you can recover from that backup, and you are up and up in within hours. So and also implement, so this is a PLC, so which is like, which can be used to control your lighting system, can be used to control your process system or monitoring. So you should have like implemented those system hardening. First, identify that device is not communicating externally, and it is sending only the information to your systems. So if you see any, you have manufactured, you purchase any devices from the OEMs, they have some kind of code which is like sending some other information to their private clouds or out of their country. So each country has a regulation, like when you, so now you buy a device from China, so all this information is, you have to verify that this device has not some code or inside it, that it is not sending out of your country or out of your process plant, which is not required. So you have to harden those, then authenticate. So when you configure those devices, you allow only the users who are engineering access or operator access to those systems. So you have clear definition what an engineer has to do, what an operator has to do, and what are the controls of our operator on this device. Then you implement the firewall. So here you can see what is the traffic going out of that device, and then you encrypt those information within your network, so that even if this information is go out of your network, but he cannot understand that traffic, or whoever monitoring to penetrate your network, he need high end algorithms to encrypt those information. Then parallelly you have monitoring and alarm system. So in case someone is trying to jeopardize your system or trying to hack, so you still have monitoring, and what is the approach he is following to in enter your network. So this concept is called defense in depth. So you have a plant level security, you have network level security, and then you have your system integrity. So you have first thing is like physical security. You should have a physical security for your process plant. You have a CCTV, and you have a security in place, and then who is entering your process plant, why they are entering. You keep a record of logging and monitoring what is the reason they are entering, like manual records, same way we do for cyber. So this is the steps you have to follow for different technologies to be implemented on your plant, so that you have your plant secured and operations run in smooth. It is same like a castle. If you see here, there is a castle here. You have a different level of security being implemented in all this. So same concept applies to a. And then you have one more logging system, which is syslog, which is an international standard for collecting all the errors, information, warnings, and alerts from those systems. And you can segregate them, and which is critical for you, which is not critical for you. So you can identify which processing based on your process as a manufacturing plant. Each manufacturing plant have different process. So you have a clear study of your process, what is critical, what is a warning, and what is an alert, and what is an emergency for your process plant. And then send this all information collected from different systems to a central dashboard. Then you have all logging there. Then you have backing up of all the data, which as mentioned, you can use different tools. We can advise you which are the best tools based on your environment. Thank you, and thank you for your time. And if you have any questions, I'm looking forward to answering it.
You have time, Rizwan. We have few minutes time left for the questions. Okay,
Yeah.
in fact, we have, I think, how much time we have? We have another 15 minutes. Okay, so I,
Okay.
I would like to, I would like you to explain more on the how this OT and IT the integration part. So one of them, see, our target audience are manufacturing units, the mid-size manufacturing units. So they have some machines which generate data, okay, and they use some protocols like OPCUA or whatever, okay. Some machines don't have that layer, okay, so they don't. There are like old machines, okay, so they don't generate data. So now the question is how this data will be connected to MES, and then MES of course connected to ERP kind of thing. So that is a usual problem what we have. Okay, so how can we manage? We can help, or how these organizations can solve this problem. Okay, for the machines which have data connected through protocols like OPCUA or MQTT or Modbus or whatever, and then those machines which don't have. That is number one. So that is the area. That is one area. The second area is, okay. So you need a strong platform of MES as per your Purdue architecture. So without that, there is a disconnect between the legs. So how what is the importance of each layer? You very nicely explained that the data will grow from one level to another level. It will not jump from one level to the higher level. Okay. So this part has to be explained very nicely. Otherwise, what happens is people think we have an ERP, and then we ERP should do everything. Okay, so these are the two areas where you can explain based on your experience, Rizwan. Your voice, yeah. Can you check your voice? Yeah, yeah,
Yeah. Can you say
yeah, yeah, yeah.
see
We
my
can hear.
screen now?
Yes, I can see.
Yeah.
Mhm.
So let me take you to this sheet. Yeah. So Purdue level. So you have this is a high level. So I will go to the next slide also to explain more deep. So you any process plants or any manufacturing plant, you have machines, right? So
Mhm.
whatever be the machines, conveyors, robots, your chimney, or whatever process you have in your company. So these machines are sometimes maybe 30-year-old machines, or sometimes they are running very good, like in this environment. So nobody would like to touch those machines or like this. And then these machines have data, so you are maybe monitoring intrusively, or you can monitor those machines by adding a new sensors, and then these sensors can communicate to external, so you can send this information. So suppose nowadays there is thermal cameras. So thermal cameras have all those information by sensing by infrared. So you know that what is the, suppose you need to send the temperature of this machine. So suppose this machine is like a motor or a process machine. So you have a 50 degrees centigrade is your limit. So you can, so this machine now has no sensor in build, but how to monitor those temperature. So you can put one way is a thermal camera there, which is like trying to capture the image of the this machine and send this information outside. So you can have SNMP based sensors, like we have different companies in the market which send the sensor information over SNMP. So they can put a sensor here and then send this information over SNMP to the PLC or a process, so MES system. So here you see there is there is a description here, milliseconds, seconds, and then here you have seconds, minutes, and hours and shift. And then you here you have ERP, which is takes the decisions based on day or month. So the decisions or the process, the information and decisions are being taken, and the manufacturing process. You see, the information and the actions are within milliseconds and second. But whereas in MES, you see like the actions are taken based on minutes, hours, and based on the shift, the operator shifts, and like this, right? So, and when this information is fed again into the ERP, so you see here it converts into days and months. So you have information per day. So how much sales I have, how much production this day I had, how much monthly production, what is the monthly production capacity of my factory. So these are informations coming out of the ERP. But MES has daily information, hourly information,
Mhm.
minutes. And then process systems, you see, the things are changing in seconds. So how many are, what is the RPM of this machine, how speed, and when it runs at this RPM, so suddenly I need to increase my capacity. So any process plant has decided we need to go increase our capacity by 10%. So you decided to change your production by over 10%. What impact it will have on your machine? So the machines which are running over suppose 24/7, and then still you cannot meet those capacity, and maybe you will have that machine to break down. So because it is already running at its full capacity, all this information can be fed into the ERP, so that you can take a timely decision, and then you don't commit to your customers like, okay, we can give you over your production capacity. So uh, you can see how well your machines are loaded. So based on those load, you can also decide your sales capacity or your commitment to the customers. So these are integration of database. So how you push the information? So you should have a process system here at this level which is collecting the information, and this system again pushes this information to the another system. So legacy, so you have a existing plant, so you can have additional controls with additional devices. We can recommend those devices how to collect those information, and then push this information to ERP for the timely decision. This is one of the scenario I have explained. So this is one of the high level architecture for any process plant. You have motors, you have robots. So if you'd like to know what information you need from those devices which is not available, and you need it additionally, then you should add more sensors in this level. So once you add the sensors at this level, then you should add the additional devices which will collect the information from this level, and then push the same information. You can send it to the same dashboard over a different protocol. So first you have to identify what protocols your manufacturing system supports. So it supports Modbus 6150, or it supports like DNP3, or a different protocol for based on your process. Identify what additional protocols your level 2 systems or HMI support, and they can push this information as a different level of protocol. So once you identify this one, then you would go and get those sensors which send those information in that protocol. So you brought a sensor, but your system doesn't support that protocol, which is SNMP. So you identified a sensor like which is sending information over SNMP. So before purchasing the sensor, go and study the systems which are existing and what protocols they accept, So go to the market and identify those sensors which send you information in that protocol. Then that protocol can automatically be integrated in this system. So you have all information from that sensor, and that information again you can push it to your MES and ERP systems. Hope I answered the question.
Yeah, yeah, that's fantastic. Now, one confusion I want to clarify.
Yeah,
Okay, so there are some systems. They say they directly connect to machine, and they say that we do generate the dashboards, and also there are some inputs given in that minimal, and then they talk about the OE calculations and all. Okay, so this is only to just to give you the machine data. Okay,
yeah,
so if you get only machine data directly at the level 0 and level 1, that is not actually enough for you to make a meaningful decisions. So
decision.
you
Yes,
need to, yeah, you need to have a level 3 and level 4. Okay, otherwise what happens is you have a limited use of the data, which is the which is maybe the manufacturing units get confused. Okay, so they say, okay, we are all connecting these machines to a software.
yeah. Now
They generate
nowadays
very
you,
nice, yeah, very
yeah,
fancy now. They get generate
yeah,
very very nice dashboards, and then they think that okay, we have a digitized. That is not correct. Okay, so
yeah,
you need to have level 0, level 1, and level 2. It is at the OT level. Okay, which you have to have a proper data collection points and then data generation points, and then level 3 is your MES. DMZ is like a connecting from outside the your plant, as
yeah,
you rightly said, and then you have a ERP. If you
yeah,
complete all these, only your manufacturing plant has a complete architecture to make use of any AI or any other data. If you have,
yeah,
if you miss any layer, it will be a problem. It will be okay. You get something, but it is not really a long-term thing. Okay,
yeah.
so you must think in that sense. So ERP, MES, and then all your OT layer. Yeah. Mhm.
Right. Yeah. Presented it right way.
Excellent.
Yeah, because there is companies like selling many products which are censored or machine to cloud. So straight away they have very good dashboard. They put sensors or devices which are placed in the field. Then they send directly to the cloud and they give you a very good dashboard. But you don't need this dashboard straight away for you, because these machines has been talking to others, or you have proper utilization of this sensor, and all this information should go through different levels as I explained. So if you have any system is connected to cloud directly, and then you don't have a segmentation of firewall. So you see here there is a firewall at this level which filters every traffic
Mhm.
which is inside the process. So you can block so this information is collected by these vendors, and they can share this information to other paid subscribers. So you don't know where this information is going about your process. So they know that your capacity is getting down. They know that all this information which you don't need the market to know, that your production capacity is down nowadays. So you are planning to so all this can affect your business, because you are pushing the information from your shop floor or production floor to the cloud, which is dangerous. So you should have a step by step approach, and then you should send any information out of your company through ERP systems or your portal systems. From ERP you can connect a portal that you need public to share, like what is you need current capacity or production going on. So you should share it to your through your ERP, and then publish it for the public data. Like you want to share something with what is the generation now. So we have many companies now which are used for solar plants and solar or wind plants. They need to send some information to the public. So what is their current generation on their website. So they are an IPP, independent power producer. So they have many different plants in different region. They are collecting the process information. So how much each plant is generating. This is for local, and also they can publish like we have this much generation per day. So this can be used in their business slides and pitch, so that see live dashboard for their production. So these all informations can be sent from here. So if you put a sensor here and a plant, and then this plant is sending all this information to directly to their website, this will ease your process, but in the long run, you cannot have the security of that plant, and all those process can be leaked to the outside.
Yeah, security is one of the one important point for sure.
Yeah,
Definitely, you should not do that. You should go through a proper security layers. And the secondly is, your information is also not complete, because
yeah,
when you collect the machine data, okay, that gives the data from the machine. To get
yeah,
the meaningful information on the overall production, you need to have the data of machines, you need to data of the people, okay, and also you need to have data of the quality kind of thing. So all these combined together, there will be the information or analytics on manufacturing will be meaningful. Okay, so
yeah,
that is exactly the problem. The mid-size manufacturing units now they're directly going to connect that, and then actually eventually they don't get any benefit of this. Yes, they will find some nice dashboards, which is the data is generating by machines. They consolidate it at the work center and plant level, but eventually it's not used. They cannot use it because in the shop floor, the production order processing is very critical. So they need
yeah,
to complete their production order properly and as per the plan. Okay, deliver it, customer service level, customer or delivery kind of thing, and then at the same time you connect the machines and then connect this machine information and put it in the layer so you have a meaningful information, okay, as a holistic. So that
yeah.
is one thing Rizwan is missing nowadays. So many people directly, as you rightly said, directly connecting from machines to cloud, and then they're generating dashboards. That definitely does not going to solve the problem. And the second problem is if they if they have established such a system, and then you want to include a MES layer, then it will become more complicated
More
because
complicated.
you have a data compatibility issues, you have other issues, and if they are not sure if this data they are putting in the cloud, is it a what kind of cloud is it? They can take it or not? How long the data will be stayed? All these are complex. So all they sell is the dashboards. That is
Yes,
really a big problem, and people manufacturing units need to be very careful about it. Yeah.
yes. See, if you see here, the machine is sending it to the cloud dashboard, and then you are collecting the information back to your MES or like this. So this is see, you see there is a round way, and then here you have a proper system. Like you don't have a sensor right now, so only that sensor which you place should talk to the PLCs or SCADA. Then you send those information to your MES. So this is the right way to get it into your MES. So instead of going getting this information back to the cloud and cloud, then you are exposing your MES directly to the internet. So this is set somewhere, this dashboard, which is Azure or Google, which is sitting out of your country, and then you are
Hmm.
connecting your MES directly. You are opening a port in your MES to collect this feed from here, which is again your manufacturing information is again connected to cloud, which you don't want to happen.
Yeah, that's exactly. So what we do in Frusi is, Rizwan, just for your information. So in MES, we have all the production order processing. We
Yeah,
also have a part of machine integrations. So this machine integrations is dedicated fully for that company. It is not outside. Okay, either it is an on-premise or a dedicated virtual machine. You connect to all machines, and then from here, you adopt proper security to connect to the ERP. So that way you don't have to worry about anything. Yeah. Mhm.
yeah, and you can have additional if you need to integrate one of the module for sensor information, which is like in your architecture or in your free strategy, your product. One more layer of application which is catering this need. So we can also offer
Correct.
to some customers so who want production information to their MES
Correct.
or your
Sure.
free
Definitely.
strategy product. Yeah,
Excellent.
sure.
Excellent. So, yeah, very, very insightful discussion. Always, I like to have a word with you. Uh, so, any final thoughts? Rizwan, what is your advice, key takeaways for the participants from your side? I hope Jyoti, next speaker, is ready. And just before concluding, stay tuned for YouTube channel because YouTube channel will be live without any breakage. So you stick to YouTube live streaming to make sure that you are not out of the session. So maybe LinkedIn sometimes, it cut at after 4 hours. So we have an issue with the LinkedIn live streaming. Okay. So Rizwan, just a final conclusion thoughts uh, from your side. So the top three key takeaways for the participants. Mhm.
Yeah. So first thing is a proper
Hello. Yeah, yeah. I lost you for a minute. Yeah.
Yeah, sorry for that. So the key takeaway would be for in process or any process plant, first try to understand your assets and define your process. Define your process into how to secure and what information you are pushing out of your process plant. So mainly asset management and what group policy you are applying for the users, who are the users, define role based access controls in it are implemented. So these are the two things we should implement, and then apart from that, once this is implemented, you can share this information anywhere. Then you have proper control, you can manipulate and you can have filtered of those information when you are sending outside the your manufacturing plant. Thank you
So
for giving
fantastic.
me this opportunity
Yeah, thank you,
and
Rizwan.
giving
Very
me
nice
talk
to hear
again.
you.
Nice,
And
nice to
ladies and
talk to you.
gentlemen, give a big round of applause to Rizwan. If you have any questions, please post it on the comment section. You will get them answered by Rizwan. Okay. So